Assalamualaikum warahmatullahi wabarakatuh and good afternoon. So today we're going to continue on our second chapter, Sinusoid steady state analysis. So this will be the part 2 of the lecture. So for this chapter we already discussed on introduction and nodal analysis. So today we're going to look into mesh analysis and superposition theorem. So at the end of the lecture, you will be able to analyze AC circuit by mesh analysis and also be able to analyze AC circuits by using superposition theorem. So let's look into the mesh analysis. So mesh analysis using Kirchhoff voltage law form for the basic analysis. So the very nature of mesh analysis is that it is to be applied to planar circuits. So planar circuit is the circuit that can be drawn on a plane surface with no wire crossing each others. So let's look what is planar circuit. So this is example of a planar circuit. So this figure is no crossing branch and this has a crossing branch which is at this branch over here. So the mesh analysis can only be done the mesh circuit can be analyzed for planar circuit, and this is a non-planar circuit. So this is a 3D circuit. We have a box, a cube with a branch, and there's a middle branch over here. So this kind of circuit, non-planar, cannot be analyzed using mesh analysis. So let's look into this example. So from this circuit, how many mesh do you identify? So basically there is two mesh over here. One over here, which is a single loop over here, and another second mesh is over here, another loop. So we have two mesh circuit. So how we want to analyze this circuit using mesh analysis? So this is the step to determine the mesh current. So first assign mesh current I1, I2 until IN to the N mesh. If you have two mesh, so you need to assign I1 and I2 to the mesh, and then apply KVL to each of the mesh. So use Ohm law to express the voltage in terms of mesh current. And lastly, solve the resulting and simultaneous equation to get the mesh current. So if you look at this example, first you assign the current I1 and I2, and then use KVL, Kirchhoff voltage law, to analyze the mesh, each mesh, and then solve using Cramer's rule. So let's look into example 10.3. So if you look at this circuit here, the value of capacitor and inductor is already in complex number, so you don't have to convert it. Even the current source and voltage source already in phasor form, so it's much easier. So the first thing that you need to do is to assign the current. So we have three mesh over here, 1, 2, and 3. So we assign the current I1, I2, and I3. So basically similar method is used in DC current, DC circuit analysis. That you already learn in electrical principle 1. So similar, only that it use complex number for this circuit. So after you assign the current I1, I2, and I3, you have to solve the circuit using KVL. So you need to get the equation. So let's look at the first mesh over here. So for the first mesh, it gives 8 plus j10 minus j2 I1, which is I1 is over here, minus j10 I3, which is over here, and minus j2 I2, which is over here. So basically, you can, how actually this equation, we get this equation is from using KVL. So basically, if you look at this current is flowing clockwise. So the first, we look at this resistor first. So for the resistor is exactly 8I1 plus, if you look at here, there's an inductor. However, the I1 here is we collide with I3. So we can write the equation like this: J10 I1 minus I3 plus the capacitor over here minus J2, where I1 is colliding with I2. Okay, so I1 is like this and I2 is going like this, right? So it's colliding. So we can write it down here, minus J2 I1 minus I2 equal to 0. So from here, if you simplify it, you can get similar like this, where 8 plus J10 I1, 8I1 plus J10 I1 plus, which is minus J2 I1. Let's write it down. 8Y plus J10 I1 plus minus J2 I1, and then we have I2 is, if you look at this, minus and minus, which we get plus J2 I2, and J3 is over here, J10 minus I3, and minus J10 I3 equal to 0. Then we get this equation. Okay, hope you understand. So let's make another example for mesh 2, which is over here. KVL mesh 2, number 2, this is number 1. So for mesh 2, we have, if you look at here, is I2 minus I1 minus J2 I2 minus I1. So it depends, the primary is I2, that's why we write I2 minus I1 compared to this here, because the primary loop is the I1, so that's why I1 minus I2 lah. And then it goes to another capacitor, minus J2 plus minus J2 I2 minus I3, and then it goes to this resistor over here, plus 4I2, and then we have a voltage source over here, so plus 20 angle 90 degree equal to 0. So if you look at this, the current is basically flowing to the into the positive of the voltage source. So that's why we get a positive. It goes to negative, it will be negative value. So if you want to simplify it, I1 is J2 I1, and then there's no I1 here, there's no I1 here, plus I2, we have minus J2 I2, and then we have another one, actually minus J2 I2, and plus 4I2, I3 over here, so it's positive because negative, and negative become positive, J2 I3 plus 20 90 degree angular equal to 0. So if you simplify this, we will get J2 I2 plus 4 minus J2 this is I1 this is I1 and this is I2, and then lastly is I3 plus J I3 plus 20 angular 90 degree equal to 0. So basically it's the same lah. We got J2 I1 over here, and then 4 minus this is 4 basically, my mistake, because there's J2 over here and another one is J2 over here, minus J2 we got minus J4 I2, and then plus J2 here, J2 I3, which is the same over here, plus 20 angular 90 degree equal to 0. Okay, and the last one is mesh I3 equal to 5 ampere. Why? Because if you look at this, there's a current source over here which is 5 angular 0 degree ampere, so automatically I3 is equal to 5 ampere. Okay, hope you understand. So for this we have 3 equations: mesh 1, mesh 2 and mesh 3. So from this here we can use Cramer's rule, or you can use website calculator to calculate and to get the value of I2 over here, because the question asks you to find I0 over here. Okay, now because we want to find I0, so basically I0 is the opposite of the current flowing of I2, so negative I2, so we get this value if you use the calculator. Okay, let's look into another example, example 10.4. So the question asks to solve V0, which is over here, in the circuit using mesh analysis. So if you look at this, we'll find out that we have 1, 2, 3 and 4 mesh. However, if you look at the middle between mesh 3 and mesh 4, there's a current source. So if it's either dependent or independent current source, what we can do, we can create a super mesh over here to make the analysis a bit easier. So please remember, if you find current source, not voltage source, current source only, you can create a super mesh between the two mesh over here, because there's a current source at the middle of the two mesh. Okay, So first you try to solve mesh 1 and mesh 2. So mesh 1 you use KVL, Kirchhoff voltage law, to get the equation, and then for I02 you can get the current by referring to this current source over here. So I2 basically is equal to negative 3 ampere because the current is flowing opposite to the current source. Okay, we get a negative, and this is equation for mesh 1 or for I1 mesh 1. And then for I3 and I4 you can get the equation for the super mesh. So this is the equation for super mesh I3 and I4, and because we have a 4 variable I1 to I4, so we need we got I1 and I2 and super mesh equation, so we need another equation. So how we get another equation? By using a nodal analysis, Kirchhoff current law at the super mesh, which is over here, point A here. So we do the KCL at this point A over here. So then we get this equation. So I3 plus IS equal to I4, where we draw the current flow like this. So IS is basically, because there's a current source here, is equal to 4 ampere. So we insert it into the equation. So now we got 4 equations, so with 4 variables or 4 unknowns. So we can use the Cramer's rule, we can use the website calculator with 4 unknowns or 4 variables to get I1 to I4. So this is the answer for I1 to I4. However, we want to find V0. So V0 over here, if you look at this, so once you know the I1 and I2 value, so you can get the V0, because V0 is equal to IR, which is I1 minus I2 times minus J2 ohm. So this is the equation. I1 minus I2 times minus J2 ohm, which is this is the capacitor, and this is the current flow, because the capacitor is between mesh 1 and mesh 2, so that's why we need to deduct or minus it, I1 minus I2. So once you put inside the value of I1 and I2, you get the V0 over here. Okay, I hope you understand. So we already discussed on the nodal analysis and mesh analysis. So now we're going to look at the superposition theorem. So what is superposition theorem? So the superposition principle states that the voltage across or current through an element in a linear circuit is the algebraic sum of the voltage across or current through that element due to each independent source acting alone. So in other words, we can say that where we consider one independent source at a time while all other independent sources are turned off. So if a circuit has a multiple source, current or voltage, you can switch on one at a time and others will be turned on. So this implies that we replace every voltage source by 0 or a circuit short circuit, and every current source by 0 ampere or an open circuit. So in superposition theorem, a voltage source is if we apply superposition theorem, it will become short circuit, and for the current source it will become open circuit. So you need to remember this. So voltage source, short circuit, current source, open circuit. This way, we obtain a simpler and more manageable circuit. So the dependent sources are left intact because they are controlled by circuit variable. So we need to consider only independent source only. Dependent source we cannot turn off or turn on. So this is the step to apply superposition principle. So first, turn off all independent source except one source. So if you have 3 independent source, you need to turn off 2 and accept one source, and find the output voltage of the current due to that active source using technique covered in chapter 2 and chapter 3. Repeat step 1 for each of other independent source. So you need to repeat the step 1. So if you have 3 independent source, you need to repeat the step 3 times and find the total contribution by adding algebraically all the contribution due to the independent sources. So let's look into this example. The question asks to find I naught using superposition theorem. I naught is over here. So if you look at this analysis, the circuit, so it is best we use mesh analysis because there's a 3 loop over here. So we have I1, mesh 1, mesh 2 and mesh 3 over here to get I naught. And at the same time, we're going to use superposition theorem because there are 2 independent sources. We have current source over here and voltage source at this side. So because we're using superposition theorem, so you need to add it says that the sum of algebraic of each independent source is the total value. So that's why we write it like this. I naught prime plus I naught double prime. So where I naught prime is due to the voltage source, where the current source is switched off, and I naught prime is due to the current source, where the voltage source is turned off. So let's look into the I naught prime. So this is I naught prime. So for I naught prime, we will turn off the current source. If you look at this, there's a current source over here and there's a voltage source over here. So for I naught prime, we turn off this current voltage. Okay. So once we turn off the current voltage, for current source, it will be an open circuit. So this circuit is not connected. So that's why we get the circuit like this, because the current source over here is turned off. Okay. So how we want to solve this? We can use either basically over here the circuit over here is been simplified. It's like this, where it will become a circuit simple, a one loop circuit. So once you get a one loop circuit, it's easier to get the I naught prime using V over Z. So Z here is the total value of this circuit here plus capacitor and resistor over here. Okay. So this is basically the value of this one because it's parallel, right? This is parallel. So I naught prime is minus 2.35 plus G 2.353. So we got the I naught prime. So now we need to find the I naught double prime. So where for I naught double prime, it is due to the current source. So the voltage source will be turned off. So let's look at the I naught prime. So if you look at this circuit, the voltage here is being turned off because it is a voltage source. It will become a short circuit, not an open circuit. So it is short circuit. So the circuit will be like this. Okay. So if you look at this, there's a 3 loop over here where I2 here is equal to minus I prime or I double prime. So I double prime is equal to minus I2. Okay. So how to solve this? We can use mesh analysis, where this is mesh 1, mesh 2 and mesh 3. Okay, so you get the equation from mesh 1 and mesh 2 and mesh 3. Mesh 3 because there's a current source, so it is equal to 5 ampere. So using Cramer's rule, you will get the value of I2. So I2 is minus I not double prime, so you get this value. So once you get this value, you have to add these two values that you get when the voltage source is turned off and the current source is turned off. So this total value here is the total current of I naught. So just add it, then you get the value for the I naught. So that's how you utilize superposition theorem to circuit analysis. Okay. So I hope you understand how it goes. So if you look at this, I just want to highlight this. If you how to convert from negative to positive, basically you just change the phase only, where 180 is minus the 23.96, so you get 156.0 degree, 04 degree. So that's all for today's lecture. We already learned on the mesh analysis and superposition theorem in this class. So tomorrow we're going to discuss more or do more exercise tutorial for these two and plus nodal analysis in the tutorial class. Okay, so that's all for today. Assalamualaikum warahmatullahi wabarakatuh.